All right, so we left off yesterday after number 6. And so we're on to number 10 today. We kind of briefly started talking about it, but it's the shortest fence. I'm not going to write the whole problem, but a 216 meter squared rectangular pea patch is to be enclosed by a fence and divided into 2 equal parts by another fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence? And then how much fence is needed? So I would start with a picture of what I think this would look like. And so we kind of talked about this yesterday, but it's pretty self-explanatory that doing it this way would be much better than doing it the other way. So I'm just going to call this width and this length. Really doesn't matter, but anyways. And I've got an area of 216 meters squared. So my area obviously is length times width. And so then we need to solve for one of these things. I'll just solve for width. So we've got basically 216 divided by L is equal to W. Now the total perimeter is obviously the 2L plus 2W like normal, but I also have an additional L in the way that I wrote it. And so we have 3L plus 2W in this situation. And so I'm going to replace W with the 216 over L. So P equals 3L plus 216 over L. Oh, 2 times that actually. So then as far as like simplifying it down, since I know that ultimately I'm going to be taking the derivative, I'm going to go ahead and write that as L to the negative 1. And I'm going to go ahead and multiply the 2 through. So I've got P equals 3L plus 432L to the negative 1. And so then I'm going to take the derivative and get 3 minus 432L to the negative 2. And then set that equal to 0 and solve. So negative 432. I'm going to go ahead and write this now as L squared, like on the bottom, just so that as far as solving it, I can look at it a little bit easier. But equals negative 3. I'm going to go ahead and like flip this stuff over so that I get the L on top. So I'll have L squared over negative 432 equals 1 over negative 3. And then multiply by the negative 432. So L equals negative 432 over negative 3, which is 144. And we're in meters.
We'd have to take the square root. Too.
Yes, thank you. I was like, that's way too big.
Yeah.
I don't know where I lost my squared, but oh well. 144 44. So then L equals 12. Give you a cookie for that. Oh, this one's a llama. Didn't know there was a llama animal cookie. All right, so then I'll take that and plug that in for to the W equals 216 over L. So W equals 216 divided by 12. Which is 18. So the dimensions are officially 12 by 18, but because that's the first thing that it asked me for. And then the total fence needed would be putting it into the perimeter equation. So P equals 3 times 12 plus 2 times 18. So it's 36 and 38. So 74. Nope. Wait. Is that 38? 36. So it would be 72 meters of total fence. So then that's technically answering both questions there. What's next? Let's look at particle motion. So a lot of or at least one question I would say on the AP exam is going to have something to do with particle motion. It could be like finding the velocity, acceleration, and jerk of that, which is what we were doing earlier. It could involve the stuff where we were finding if it's accelerating, decelerating, all of those things like we were doing in the last section, or it could involve this optimization stuff. And then once we get into stuff with integrals, it'll be like kind of working in reverse. And so I would pretty much guarantee there's going to be one problem that deals with that stuff as a short answer for your response question. So we're going to look at one of these as like an optimization problem here. And so 14. And this is technically, because these are more like word problems, like more practical things, this is like actually a vertical motion problem, not just like a particle, but anyways. The height of an object moving vertically is given by S equals negative 16t squared plus 96t plus 112, with S in feet and t in seconds. And then, so the first thing is, we'll just work step by step. The first part is to find the object's velocity. Can't spell. When t equals 0. So basically with this, I just need to, well, first of all, I need to find the velocity equation by taking the derivative. So v of t is equal to negative 32t plus 96. And then I need to set t equal to 0 now for the, actually what they're asking me for. So v of 0, just negative 32 times 0 plus 96. So 96, did they give me units? Oh yeah, S in feet and t in seconds, so feet per second would be the velocity when the time is 0. So essentially, back to physics class, that would be finding like my initial velocity basically. Part B says to find its max height in when it occurs. So this is where the optimizing part technically comes in. So if we take the velocity equation and we set it equal to 0, and that kind of hopefully will make sense if you remember, like at the top,
Yeah.
it's going to momentarily be 0. So that's going to be the max height. So we take the negative 32t plus 96 and set it equal to 0. So negative 32t equals negative 96. Divide by negative 32, t equals 3 seconds. And then it wants to know the max height. So that's when it occurs. So then to find the actual height, we're going to plug this number into the position equation. And so S of 3 is equal to negative 16 times 3 squared plus 96 times 3 plus 112. And that is equal to 256 feet. So at 256 feet, or at 3 seconds, it's at its max height of 256 feet. And then part C, the last part of this one says, find its velocity when S is equal to 0. So basically when the position is 0, we're going to solve for t essentially in that. And then we're going to plug those times into our velocity equation and solve for those. So I've got negative 16t squared plus 96t plus 112 is equal to 0. A lot of times it works out nicely where whatever number is in front of your t squared will actually come out of all of the pieces, which is nice. And I think it does with this one as well. Yeah. So I've got basically negative 16 and then t squared plus 6t plus, nope, that's a minus. Both of those are minus 7 because I took out, I went in and took out the negative. So then that's 0. So then I've just got, the negative 16 is going to go away. I'm just going to cross it out instead of rewriting the whole thing. And so then factors here, t plus 7, nope, t minus 7, t plus 1. And so then basically t equals 7 or t equals negative 1. Well, I know I can't have negative 1, so I'm going to cross that one out because I can't have negative time. And then I'm just going to take this and plug this into my velocity equation. So v of 7 is equal to negative 32 times 7 plus 96. So that's negative 128 feet per second. And essentially that would just be telling me that the velocity is going in the negative direction at that point, not that the actual value is negative, obviously. These problems are where it's like handy to be in physics and calculus at the same time, because when somebody's just taking calculus and like not physics, sometimes they're like, how's that possible? Because it's like, they're like, are they slowing down? I'm like, oh, no, not necessarily. Okay. All right, the next question in your book actually goes on to 2 pages, but it's designing a box with a lid. So I like to think about like shoe boxes when I think about that. I feel like it's easier to kind of visualize one. But we've got a piece of cardboard that measures 10 inches by 15 inches. And then it says 2 equal squares are removed from the corners, and they're going to give a picture, so I'll draw the picture in a second. 2 equal squares are removed from the corners of a 10-inch side as shown in the figure. 2 equal rectangles are removed from the other corners so that the tabs can be folded to form a rectangular box with a lid. So I'm going to do my best to draw this box here.
Hello.
Hey.
Hey, I've got some more cornhole boards and ice cream.
Okay, I'm gonna try to finish up is it somebody like bringing it all together, or is it already in the office?
Mrs. Alexander, where is it at? I see ice cream in your hands. Chris is at the bottom of the stairs with the cornhole boards, and she's got ice cream in her hands.
Okay. Would she be okay with bringing it up to my room so I can finish this math problem?
Yeah.
Or she can leave it in the office and I can come get it when I'm done with this problem that we're doing, because we're on our last one, I think.
Okay, well, she has help with Chris. I'll ask.
Okay, the cornhole boards can go in the back room of the gym if he wants to take them in there, if he doesn't mind.
Okay.
But the ice cream can come up to me
through the
if...
back door.
Yep. Okay.
Thanks.
Thank you so much.
Uh-huh.
Bye. Like I said, it's going to be an all-day affair. This is not a good picture.
So they didn't give you a picture?
They did. I'm just trying to...
Okay.
I'm trying to replicate it so it's easier to look
Yeah.
at, but I'm just not doing a very good job. Close enough. So they gave me this, and then they tell me that this is the base and this is the lid. So this is the part that's been cut out, the rectangle that's been cut out from this side, and then this is the squares that have been cut out over here. So this is 10 inches. I love that the picture in the book says not to scale. And then this is 15 inches this way.
Okay.
And then basically, I'm going to do it a little different than they showed in the book. I'm just going to show that these each are X here because it's easier to do it that way. And then X, 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 and X. So the lid is the same size as the base, in theory, is what it's supposed to be showing you. I've just written these here instead of they put little X's and then draw the arrows everywhere that they're supposed to be. It's just, yeah, anyways. Okay, so that's my box with my lid. So then part A, write a formula V of X for the volume of the box. So I need to kind of figure out what each of the dimensions are first. So I need to kind of figure out what my like length, width, and height are. So, because volume of a rectangular box is going to be length times width times height. So
I'm supposed to tell you.
if you have a second, would you mind sticking it in Chelsea's freezer since
No.
you brought it up?
Okay, boards are in the back storage unit.
Yes, perfect. Thank you.
I thought, what they tell me?
This has been every class period I've had to go get something, and I was like, I need to finish teaching this problem. Thank you.
They said, can you? I said, sure.
I appreciate it.
I said, what am I supposed to remember now? Okay.
She called me, but I was just gonna, yeah.
Okay.
Thank you. Okay. So my height is going to obviously be like, you know, the box when it's folded. So it's going to be the X value here. I don't know why I wrote an L. H equals X. And then my length is, I know I'm cutting out, actually this is length, sorry. The length is obviously going to be this 15 inches, but it's going to be cut in half, okay, because this side and the base should be equal to this side and the base. Because to make a box, you have to fold the whole thing up and over to do
like
that.
The two rectangles on the side of the base, we're just like cutting those because we're like folding them up.
Well, that's going to be for the width.
Okay.
Because I'm going to do, so I've got to do the length and then I've got to do the width as well. And the width is going to basically be done the same way. It's going to be slightly different because it's not the whole thing. So this whole piece is, like, this is one huge piece of cardboard right now. Well, 15-inch long piece of cardboard. So then I'm cutting it in half essentially to look at the actual length of the piece of cardboard or the length of the box. So this whole side is 15.
Mm-hmm.
The length of the box is half of that because the other side is getting folded up and over.
Oh.
So this side and the base is half, and then this side and the lid is the other half of the cardboard.
Okay.
So the length is going to be 7.5 minus the value that I cut out, which was X, because that's the length of the sides.
Okay.
So I'm taking that off by doing this. Then the width, I'm kind of doing the same way. So I've got 10 inches this way, but I know I'm cutting off X here and X here, so it's going to be 10 minus 2X because I'm not making the lid off of the width part.
Yeah.
So this will be 10 minus 2X.
So how come the length isn't 7.5 minus 2x?
Because I've already cut it in half. So only half of the box, I only need to remove 1X.
Okay.
Because I'm removing this part. And then this is just the duplicate version of it.
But wouldn't, like, if you had the box and then you, like...
If I did that, then it wouldn't be 7.5. Because the lid is only going to be some portion of this. Because the lid and the base are the same size.
Mm-hmm.
I mean, obviously, hypothetically, they're probably not exactly the same size if you think about a shoebox. But... And then the part that the sides that are getting folded up. I have 2 of them, yes.
Yeah.
But I only really need to look at half of it to make the length of my box.
Oh.
Is half of the total length
Okay.
minus the part that's getting folded up on a side. This
Okay.
part that's being folded is being accounted for with the lid.
Okay, that makes sense.
It is confusing. The first time I did this problem, I was like sitting there like looking at it and I was like, okay, I have to process how this works. And like, if they didn't give me a picture, I probably would never have gotten to
No, I was
the
actually
thing.
confused with what you're talking
Fortunately, most of the time they give you the picture. Like there's one, I think one of the ones that I'll probably like give you, it's a long problem, so I probably won't give you all the parts. I'll give you like pieces of the problem, but it's like designing a suitcase with like the pieces or whatever. But then it's like, okay, every suitcase is different, so you kind of have to like not overanalyze the kind of suitcase that it is. Like, yeah, it's like, okay, you're basically just making a giant box on wheels.
Yeah.
So at this point, I'm going to put in the formula, so V equals 7.5 minus X times 10 minus 2X times X. And then I'm going to FOIL. And so then I get 75 minus 15X minus 10X plus 2X squared. And then all times X. So that ends up giving me 75X minus 25X squared plus 2X cubed, ultimately. I'm skipping part B because it says to find the domain of this, which basically they just want you to graph it and then say what x values this could take on. But we don't really need to do that part. It's not really that important, so we're going to skip that part. So part C, use a graphical method to find the max volume and the value of x that gives it. So basically, at this point, I am going to plug this equation into my calculator to find the max volume, and then I'm going to actually use my calculator to find the maximum for me.
It said find the max volume.
Yes.
Okay.
Let me write that. And then it also says in the value of x that gives it. All right, so graph this equation. And so I may have to, because I can't see my entire graph, I may have to do like a zoom fit to get it all on here, and then I can do my stuff to find the maximum. I did a zoom fit, so it's like zoom, well, it's zoom 0 for me. I don't know if it's the same thing for yours or not, but.
Mine just looks different. Like it shows the going up through the axis too, and then up on the other side.
I think the newer ones just show more than
Oh.
the older ones. So basically what I'm going to do is I'm trying to find the max volume and where it occurs. And so what I'm going to do is obviously a cubic function is going to keep going. So I know that ultimately, like, I can't go all the way out because it's not possible. Like,
Yeah.
my x has to be somewhere between, like, smaller than 10, because otherwise then it removes the whole box. And even then it still can't be but so large. So if you hit second trace, you'll see maximum. And then I would just take my cursor and arrow over arrow over a little bit, and then arrow to the right until basically,
It's going up.
yeah, it's going up. And then you're gonna see the, like, so what I'm noticing is at, say, like, x is a little bit bigger than 1.5, the value's still going up to almost 2, and then after 2 it starts going down. So at any point after that, I'm gonna hit enter.
Should I keep it all within 10, or does it really matter? Like where x is 10, or can I go like past that?
Mine I did from x being like -3 to being like +3,
Okay,
basically.
start that. I might be zoomed out or something, 'cause I don't know what's going on.
Do you see in the bottom left corner, like, the little, it'll say like x equals whatever, and as you move it left and right, is that changing the x value?
Yeah.
What x value is it giving you?
So like, I'm just moving in, it's going up like 2 every time. What did you mean? Like when I move it, what does it give?
Like, so when I hit second trace and then max, as I move this over, this number is going down. So right now it's going down. It's like 0.42, 0.20, -0.2, -0.4, -0.63.
No, yeah, mine's going down, but it's going down by like a lot. Like,
Did you hit zoom fit?
yeah.
your Zoom, I forget. So Zoom Fit on mine, it's gonna show me like the main part of it. Zoom Fit on the new ones actually does it a lot bigger. So once you do this, you might actually want to hit Zoom Box,
Okay.
and then like go down here and like just do something in this like general vicinity. That's a lot. And do like that. What?
That's what I'm saying. Maybe I typed it in wrong.
75x minus 25x squared plus 2x cubed. I think that's what it was.
Oh,
wasn't it?
yeah, that's what it is. I have no idea.
Let me just change your window instead. Let's do x min -3, x max +3, scale of 1. Let's do the y min of, I know it's gonna be higher than 0, so, and then let's go up to, let's just say like 80, and then scale it by 5.
What does that do?
This is just me changing the window, so then once you do that, you just hit graph, so now I can see your max, and then you would just
Okay.
do that there. I guess that's kind of the downside to the calculators. The thing you have to remember is if you change the window manually, which can be good, because then you can scale it however you want. So if you want it to like look like a specific graph or whatever,
Yeah.
you can do that. However, kind of like a lot of people when they hit that, then they go hit Zoom 6 again, thinking they need to do that to produce the graph. And as soon as you do that, it resets the window. So when you do that, just hit the graph button afterwards, and then it will produce whatever window that you just gave it.
Okay.
So now if you did your max and your min, or not, I don't know, you don't need a min. I don't know why I said min. Did it work that time?
Yeah.
Okay. So I basically get that the x value for the max is 1.96 and that the y value is 66.02. So the max volume is basically 66 inches cubed. And then the x value that you're cutting out to produce that box is 1.96 inches.
You did x is -3?
On the window,
Or like when you put your max? When you
I did because mine is so zoomed out. For you, I would just go over from like, I mean, you just need to be to the left of the hump and to the right of the hump.
Okay.
So like yours, you could actually clearly see, like, well, on yours, you could see like this much of it, I think. On mine like does this thing and like levels off and then just keeps going, so it was hard to tell where it was. So I just watched my y values go up, and then when the y value started to come down again on like that bottom right corner where I was doing the max, then I was like, okay, well, I can stop now because I know I've gone past the max because it's changed from
Yeah.
like essentially from going in the positive direction to going in the negative direction.
I realized I put my left bound on the right side.
Oh.
So.
Yeah, that'll do it. And technically, like, out of Zoom standard, we could still run our max. Let me get if I can get mine to run. Because I could still calculate the maximum value just on this side. I could just do it as like, okay, well, I can tell my graph went up and came back down, so I could just do this, and then I could just arrow over until I see it come back over here, and it should still give it to, yeah, it's still going to give it to me even if I can't see the whole graph. As long as I know which, I realize you can't see it. As long as I know which direction it went, like, it's fine.
Okay.
So I still, like, I basically clicked it over here, and then I just arrowed till I saw the cursor flashing over here, and then I hit guess, and it gave me the exact same thing.
Okay.
And it could potentially be off by like a couple decimal places. I have had that happen where like I have a bigger class or something, and then like several people get different like values by like, but it's normally like not the first decimal place, but like the second or third decimal place it'll be off a little bit. And so just sometimes that happens, like I guess with the way that your calculator like rounds it. Like I have a feeling Cash's calculator would give me something totally different because his calculator is weird. But so that would just, so this is really just the answer here. This is the max volume and this is the X value that gives me that value.
Okay.
Now they technically say to confirm it analytically as part D, and so to do that, we would take the derivative of my, I keep wanting to say velocity, my volume equation. So the derivative of volume would be 75 minus 50x plus 6x squared. And then we would set that equal to 0 and solve. And being that I am aware that this value is a decimal and not a whole number, I know that I'm not going to be able to just factor this. And so I'm just going to stick it into the quadratic formula to do that. So 50 plus or minus the square root of 50 squared minus 4 times 6 times 75 all over 2 times 6. And I'm going to solve it this way, and it's going to give me two values. So I'm just going to plug it into my calculator if I'm being completely honest. Or at least the stuff under the radical. So get the square root of 50 squared minus 4 times 6 times 75. So just as an approximation, I'm just going to go to two decimal places. So I get 50 plus or minus 26.46 over 12. Minus. When I do the minus one, I get 1.96. When I do the plus one, 50 plus 26.46 divided by 12. When I do the other one, I get x is equal to 6.37. But I know that's going to be way too big because I cut it out from both sides. Well, if the total side is 10 inches, I can't cut out 6 inches from both sides. So I know that number doesn't work, so I can just cross that one out.
Okay.
So this is just the way we could have done it by hand.
Oh, I'm seeing that. Okay.
So more so, a lot, they're not typically necessarily going to ask you like as an AP exam question. If they were to ask you an optimization question, they're not necessarily going to ask you to do it graphically and then also do it analytically.
Yeah.
But it's kind of just like two different methods that you can use to find the exact same information.
Okay.
And then it's just looking at the practicality of it. Because technically our calculator would have also produced this number for us, but I could tell that that was going to be way too big, so I didn't even arrow over
Right.
that far. Because I'm,
Yeah.
looking at the picture, I understand I don't need something that big. There's one more type of problem in here that's a cost problem, but I think at this point I'm just going to hold for Monday. We might look at that one on Monday. I'm going to go ahead and write down the problems from this section for you, but Monday, if we do that problem, we'll start with that, and then you'll just have time to work on the problems that go with this. I'm leaning towards a quiz on Wednesday on 5.3 and 5.4, because we got physics on Tuesday, and then that way, you have time and don't have to worry about this weekend with all the things. So, but just so that you have them if I decide we're not going to do the other problem. I go back and forth. They're annoying problems. They're minimizing cost problems, anyways. They're really good for business, but are you really going to use calculus to minimize the cost for your business? Probably not. You're probably going to use a statistics function, so but I need to refresh on if it's a thing for the AP exam or not. I feel like it probably is since I covered it last year, but I don't remember for sure. Anyways, so 3, 9, 19, 25, but that's the one if we end up doing the cost problem, so you won't know how to do this one yet, so just ignore that one for right now. And then 30 is an interesting one. It's a thing about the post office and like knowing if your package is gonna like ship for like in their regulations and stuff. It's kind of interesting. So